Welcome to the video tutorial for the first of two lessons on circles in the shapes family. First lesson, which is called Circles 1. In the past I have called it cups and saucers because it's a practical exploration of pi as in the circumference compared to the diameter of a circle. It's a practical exploration. And I think it's important that children realise in terms of ratio that it comes from something. It's not said in the past in these videos, it's not a number and it means something. It's come from a relationship between two features, whether it's a river, whatever. I mean, pi's everywhere. And I think it's just lovely to introduce children to understanding of maths from that point of view, that people have understood this relationship and applied it. And now we get the number and they think pi is just a number. No, it's not. It's a relationship. It never ends. There's a book by an autistic guy whose name escapes me, who remembered pi to 22,000 decimal places. And it's fascinating to read the chapter in his book where he recounts that and he won the competition. So it isn't just a number, it means something. In America, you've got Pi Day. I've got a friend who's a head teacher who always does an assembly on maths on the 14th of March. So it's a practical exploration. There are two options for this lesson. There's the standard one, which many people do, or there's another version of it. I'm going to talk about the standard version because it's very practical and it just gives you the option of going with that one or trying a different version. You might want to do two different ones with both classes. It doesn't matter. It's the same scenario. The second version involves a boy or a girl who's left school and is heavily in the Duke of Edinburgh, and they make a tent. And their tent is very, very simple, and it's just a semicircle. And what you ask the pupils to do, there's images at the start to say which is the semicircle and how do we know. And there's a good chance at the start of both lessons to draw, good opportunity to draw out the language of circles, circumference, radius, diameter, area, all that kind of stuff. So in the version in the folder that you've got, they compare the height of the tent with how much fabrics need to go across. So you're comparing the radius with half the circumference, and the relationship is the same. Though there's other version of the lesson, which is very practical, and I think it's important. I'll show you why when I'll show you some flip charts from an actual lesson that I taught about three weeks ago. Is I would start with three very similar sized circles spread around the room with different orientations, and ask the pupils to tell me which is the biggest. And in year 7, they struggle to describe how big circles are because they just don't have the language. They don't have they've not come across areas of circle before. And that would then elicit the language of, well, the size could be how far across it is, diameter, or all the way around. In the class, the resources from the class I'm going to show you, I can't remember what they called it, but they didn't call it circumference. I said I called it circumference, and they used another. They called it the orbit all the way round, which is fine because you're approaching formal maths, so the language can come later. So in this particular lesson, I'm going to show you the resources that you use, but it is a practical exploration. I think sometimes the interesting about these lessons is they do change depending on the context of your life and what you're thinking about. I think that's good. You can share your thoughts with pupils and use the lessons as a vehicle for developing mathematical thinking, but to make them think about the things that interest you mathematically and problems in the world. So they are flexible enough to adapt. And I remember once my nephew came to my house and he ran into the kitchen. He said, "There's loads of circles. There's loads of circles. There's not many squares." I said, why are there more circles in the kitchen? What's he found? And so I have a box of circular things. You have a look. All things that I've found in my house, in the kitchen, in the cupboards. I mean, they're everywhere. The world is full of circles. I think children don't realise that pi, this relationship, has come from these circular objects. And so I said to them, we now know you've got the circumference and the diameter. What I'd like you to do is I'd just like you to compare them. And it's important to have a range of objects because we are dealing with approximations here. We're not dealing with exact numbers, and that's where it becomes really interesting, as you'll see from the lesson. So what you've got is the children explore as many of these as they can. Look at the circumference, write down the circumference, write down the diameter, and do as many of them as they can. I would say 5 or 6. Whichever version of the first circles lesson you do, whether it's the string with the circular objects or the measuring the height and the amount of fabric needed for a tent, they all follow a similar pattern, and it's this idea of developing the thinking from how the pupils interact with the stimulus. So nothing is given, everything emerges from the pupils, and I think it's a really interesting way of working with children, watching a class learn and develop and communicate. There's a lot of focus on dialogue and reflection in these lessons, and often that will happen when you hear peers say things. This is part of the theory behind the approach, which comes from the Russian psychologist Vygotsky, which talks about the interaction of thought and language and listening to someone who's more able. And in these lessons, it's the language of a peer who's a similar age that's actually more helpful in your thinking than me, who's formally educated, who's old. So we're really utilising the power of collaboration, the power of peer support and familial language. So whichever version of the lesson you use, they follow a similar pattern. So you have this idea of developing the emerging language. So you can see what happened here. They've ordered on orbit. For this one, they wanted to call it the diameter. But here they had the orbit, and I put circumference, and 3 of them voted with the 10 votes for orbit. This is where the lesson gets interesting, because we're dealing with real numbers. Everything emerges from measurements that are messy. And I think it's important to include objects, either real fruit or things like that, where it's really hard to accurately measure one of the variables, either the diameter. These are all approximations, so children are seeing the relationship. It isn't exactly 3, so it's not like chanting times tables or counting back in 3s. It's difficult to see because they're dealing with real numbers and messy numbers. So these are the measurements that the pupils took. And I said, do you notice or spot anything? And they all spot things in the decimals. But there was 3 interesting observations that came up that focused the class. One child said, this is always less than half of that. Some of them said this is always bigger. Some said this is roughly 3 times bigger. And I felt the language of that particular boy used roughly was really interesting. I said, well, there's 3 observations. Which do you agree with? Which do you think is the most interesting? Which do you think is the most fruitful, the most productive mathematical relationship? Because this takes a while for them to measure and write it all up here, and then they're standing back and they're looking and saying, well, can you see any patterns? And I think a lot of maths is given to children rounded and tidied up, and they don't have a chance to deal with real figures. And I think that's where the problem later on comes from. So what the class decided to do was, they had a debate over this roughly 3, because they felt that less than half wasn't very accurate, always bigger wasn't helpful, and that how much bigger? Oh, it's roughly 3, and they could see that, and they started talking about the results. So we started exploring this. What does this roughly 3 mean? So what I found a big hoop that the diameter was 27. I said, okay, predict the orbit or predict the circumference. And we had all of these, and so then I measured it and said, oh, it's 85. And they said, oh, not times 3. It's roughly 3, it's about 3. What should we call this? And then I said, well, I'm going to do a division. I'm going to divide that by that. And I got that, 3.14814. And is that roughly 3? How can we describe that? 3 and a bit, roughly 3. What does this roughly 3 mean? Oh, how far round is roughly 3 times bigger than how far across? So what I didn't have time to do, because the discussion was so rich, I didn't have time to give them some proper circles drawn on card and actually ask them to measure down and predict the circumference and check it. And then you go through a period of averaging it to realise that it's actually 3, it's a bit more than 3.14. And then to end the lesson, because the bell was about to go, I told them a bit about pi, because it was on the 16th of March I did the lesson, so it wasn't long after Pi Day, and talked about some of the areas where pi has emerged and amazed people. And I think there's an opportunity here to do some really interesting ideas on the history of maths, the development of mathematical thinking, some current research into pi or whatever. I just think it's a really, really interesting lesson to share in children the history behind a number that's can we have a number that's 3 and a bit? Is that really a number? And what does the number actually mean?